Yes, this is called as what here parameter estimator. The parameter estimator is nothing but see the entire population, whatever we consider for study, on that entire population it is not possible to conduct a simulation. So that normally what happens, random numbers will be chosen, some sample data is chosen from the entire population, and a particular parameters will be estimated. A parameter is nothing but what here, a sample mean, sample variance, and some of the statistical parameters, those are belonging to entire population. Estimator is nothing but a sample mean and sample variance, which are related to the small sample data. So here the Poisson distribution parameter is what here alpha, then the estimator, the corresponding estimator is calculated by using what here alpha cap equal to x bar. And similarly exponential distribution is having a parameter, that is lambda, and it is calculated by using the equation lambda cap equal to 1 divided by x, so on. And gamma, in case of gamma distribution, two parameters will be calculated. In case of normal distribution, that is mu and sigma square will be calculated, and in case of log normal, two parameters are estimated, right? See here alpha cap is nothing but estimator, right? And alpha is what here parameter. Okay, so in case of lambda, the lambda is a parameter and the lambda cap is what here estimator. So one thing we have to remember is the parameter is related to the entire population and estimator is related to the data, a sample data which is chosen from the entire population, right? Yes, the next step is what here, the third step is choose a parameter that determine a specific instance of a distribution family. Once the specific distribution family is chosen, the next step is we have to estimate the parameters of a hypothesized distribution, right? A parameter can be estimated by using three different equations here, three set of the equations for computing a sample mean and sample variance. So let us see first case. In case of first set of the equation, so this is related to the observation in a sample of size n, say x1, x2, xn, which are discrete and continuous. Then the sample mean and sample variance are calculated by using these two equations, right? So where xi is nothing but the value of the random number which is there in a sample, right? So let us consider one example. Here a data is given. So this data is what here raw data, right? So any interpretation has been not done on this data. So this is a part of the entire population. Some random data, random sample has been selected from entire population, right? The total size of this data is say 50. The n equal to what here, what is the value of n? N equal to 50. So how this how the sample mean is calculated here, that is parameter x bar is nothing but sample mean. This is calculated by using this particular equation, that is summation I equal to 1 to n xi divided by n. So here sum of all the numbers, all the sample numbers divided by total number of the sample data, right? So the sample mean of this data is what here, that is 11.894, and variance, that is s equal to 24.953. Yes, the second parameter estimator is what here, when the data is raw data which is unavailable, and the data are grouped into class intervals, right? So actually from the data, from the original data, it is grouped into class intervals, but that original data is not available. So just now we have seen one of the technique where the parameter is estimated for raw data, right? From that raw data it is interpreted, right? So this particular table has been constructed. So this is what here, a group of the data which is which is like what here, the class intervals, right? So when such a data is given, then how the parameter is estimated? The parameter x bar is nothing but what here, this is estimated by using the particular equation, that is summation j to 1 to c fj mj, right? So here fj is observed frequency in jth class interval, and mj is the midpoint of jth interval, and c is the number of the class intervals, right? So here let us consider the first class interval, where the xi is what here, xj is greater than or is equal to 0 and less than or equal to 3. So here the what is the frequency, what is the value of fj here? So the value of fj in first interval is 23, and mj is nothing but that is 0 plus 3. So midpoint of this jth interval, that is 0 plus 3 divided by what here, 2. So how much we get? That is 1.5. So that 1.5 is multiplied with what here, the frequency, plus, so we consider the second class interval and its midpoint, that is multiplied with the second class interval frequency, so on, right? So for all the values we will calculate this, and the entire value is divided by what here, the total number of the sample size. So how much we get? We get a 12.28 as a sample mean, and variance as what here, 605.849. So this is when a data is grouped into class intervals. So when the raw data is not available and it is grouped into class interval, that time we will use the following two equations to find sample mean and sample variance. Yes, this particular case is when the data are discrete and have been grouped into frequency distribution. So let's consider an example. So here whatever the data they have given, so which is related to the number of arrivals of vehicles in a 5-minute period. So the data they have grouped into what here, frequency distribution. So the sample mean is calculated by using this particular equation, and sample variance is calculated by using this particular equation. So here fj is nothing but the frequency observed with respect to what here, xj value. So the first value is having how many frequency, 12. The second value is having the frequency as a 10, and so on. So the first value, that is 0, is multiplied with the first frequency, plus the first, that is 1, is multiplied with the second frequency, so on. It will be calculated. So all these values are substituted into this equation to find sample mean and sample variance, right? So once again I will repeat the thing. See, when the data is the parameter estimator, the following are the three set of the equations which are used for parameter estimation. When the data is raw data is available and which is discrete or continuous, then these two equations will be used for finding sample mean and sample variance. And when the data is raw data is not available, but the data which is grouped into class interval, that time we will use these two equations for finding sample mean and sample variance. And when the data is grouped into frequency distribution, we will use these two equations for finding the sample mean and sample variance. So the last step is what here, evaluate a chosen distribution and associated parameter for goodness of fit test, right? So here once the data is available and associated parameter is chosen, the fourth step is what here, to check whether that associated parameter and assumed distribution will satisfy the distribution of the data or not, right? So here two test methods will be used, Kolmogorov-Smirnov test and chi-square test, right? And chi-square test, so we know already the test statistic equation of chi-square test is given below. So that is chi-square equal to I equal to 1 to k. So k is nothing but what here, the class intervals, and OI is nothing but observed frequency in ith class, and EI is expected frequency in ith class bracket square divided by what here, ei. So ei is nothing but expected frequency in ith class. So this is calculated by n into pi. So where pi is theoretical probability value and of ith interval, right. So after that what we do, next we will check the computed value with what here, we check the computed value with the tabulated value. So the tabulated value is obtained by using this particular equation, that is chi square alpha k minus s minus 1. So where k is number of the class intervals and s is the number of the parameter minus 1. Okay. And some of you will be asking that what is the recommended number of the class intervals. So this table shows the how much class intervals we have to select for solving the particular problem using chi square goodness of fit test. So if the sample data size is 20, then do not apply chi square test, because it will not give a good result. When it is 50, then 5 to 10. When the sample data is 100, then 10 to 20. And if the data is greater than 100, then we will use square root of n to n divided by 5. So within this range we will use a number of class intervals, right. So thank you. Please subscribe to my YouTube channel to see more videos on system modeling and simulation.